Proof by contradiction. Watch the previous video on proof by contradiction to show that root 2 is irrational. It's in a bit more detail than this video. So we start off by assuming that root 3 is rational. So we're contradicting this statement. So we write root 3 as a fraction where a and b are integers with no common factors. We square both sides, rearrange to make a squared the subject, and we see that a squared is a multiple of 3. If a squared is a multiple of 3, that means a is a multiple of 3, and we can write a multiple of 3 like this. So I've replaced the a here with 3n to get this. Expand the brackets, divide both sides by 3, so now we see that b squared is a multiple of 3. If b squared is a multiple of 3, that means b is also a multiple of 3. So now we have shown that a and b are both multiples of 3. If they are multiples of 3, then in this fraction a and b have common factors, but we said earlier that a and b are integers with no common factors. So there is a contradiction with what we said earlier, that there were no common factors here, which means that root 3 is irrational. Root 3 is irrational. Our assumption that root 3 is rational was wrong. Okay, now applying the same proof for root 5. So we need to show that root 5 is irrational, so we start off with a statement that contradicts this. So we're saying root 5 is rational. We write root 5 as a fraction where a and b are integers with no common factors. We square both sides, and then we make a squared the subject, so a squared is a multiple of 5. So if a squared is a multiple of 5, that means a is a multiple of 5. So a can be written as 5n. So now I'm going to replace the a with 5n, like this. So we expand the brackets, gives 25n squared, divide by 5 on both sides, and now we see that b squared is a multiple of 5. If b squared is a multiple of 5, then b is a multiple of 5. And we already have this, that a is a multiple of 5. We said earlier that root 5 was equal to a over b, where a and b are integers with no common factors. But we've just stated that a and b are both multiples of 5, so 5 is a common factor to both a and b. So this contradicts the earlier statement. So we have a contradiction which shows us that root 5 is irrational. So this assumption that root 5 is rational is wrong.